object, just as numbers, variables, and expressions are types of mathematical objects. A matrix is a rectangular array containing individual elements or entries enclosed in brackets. The entries of a matrix can be numbers, symbols, expressions, or any type of mathematical object for which the operations of addition and multiplication have been defined. This requirement is necessary since some matrix operations involve addition or multiplication of individual entries. The entries of a matrix are arranged in rows and columns. And a matrix can have any number of rows and any number of columns. A matrix of m rows and n columns is said to be an m by n matrix. For example, this matrix is a 4 by 5 matrix. So we say that the dimension or the order of this matrix is 4 by 5. The order of a matrix is always given as the number of rows, followed by the number of columns. The rows of a matrix are numbered from top to bottom, starting with row 1. And the columns are numbered from left to right, starting with column 1. The position of an entry in a matrix can be specified by its row and column numbers. These are called the indices of the entry and are written as subscripts following a variable which represents the entries in the matrix. For example, if we choose the variable a to represent an entry and I and j as the subscripts, we can refer to the entries by writing a, where the first subscript I is the row index, and the second subscript j is the column index of a given entry. For example, we can specify the entry in the third row and second column of this matrix as A with subscripts 3, 2. In this array, the value of that matrix entry is 1. The main diagonal of a matrix is composed of all the entries whose row and column numbers are the same. One special type of matrix is a square matrix. Square matrices have an equal number of rows and columns. If the number of rows and columns in a square matrix is n, we say that the square matrix is of order n. For example, this square matrix is of order 4. An upper triangular matrix is a square matrix whose entries below the main diagonal are all 0. The entries in the main diagonal and above can have any value, 0 or otherwise. Likewise, a lower triangular matrix is a square matrix where all the entries above the main diagonal are 0. In a lower triangular matrix, the entries in the main diagonal and below can have any value. A diagonal matrix is a square matrix whose entries above and below the main diagonal are 0. Other special types of matrices are matrices with only a single column, called column matrices, and matrices with a single row, called row matrices. Another special type of matrix, which is useful for solving systems of linear equations, is an augmented matrix. As we mentioned in the beginning of this lecture, augmented matrices are used to represent systems of linear equations in a compact, easy-to-manipulate form. Augmented matrices are like other matrices, with the addition of a vertical line and an additional column of entries to the right of that line. Each row of the augmented matrix is a shorthand representation of one equation of the system. The columns to the left of the vertical line contain the variable coefficients for each equation. Any variable without a coefficient is considered to have an implied coefficient of 1. And any variable in the system which is missing from an equation has an implied coefficient of 0. The entries in the column to the right of the vertical line correspond to the constants on the right side of each equation. We can think of the vertical line in the augmented matrix as corresponding to the equal signs in the equations.